Okay, so let's start with this week's remedial session. Like you guys have requested to discuss the remedial paper. Your short test paper, right? So the solution is already uploaded on your Moodle, right? Just in case if you need to access it, it's already there, right? So let's start. Problem number one. You need to sketch x of n, y -2 minus n given x of n and y of n as follows, right? So you can see this particular term over here, this one, the highlighted term, right, that we have here. It indicates multiplication, right? This term indicates multiplication, not convolution. If there was a star sign over here, right, that would have indicated convolution. So most of you made an error in that particular sense, that you have tried to perform convolution, while some of you made an error transforming this y of n graph as -2 minus n, right? So the order of operation for transforming a graph is, the first thing that you'll need to do is to shift and then reflect, right? Always remember that you need to shift and then reflect. So in this particular case, the x of n graph is as it is, right? We don't have to touch that. We don't have to do anything with that, right? But regarding with the y of n graph, we'll need to transform it, right? We need to perform a certain operation in that particular case. So it has two translation in this case. That is, you'll need to shift by negative. Shift by 2 units to the right, and then you'll need to reflect it, right? So if you shift 2 units to the right, right, in this particular case, if you shift this graph 2 units to the right, so your axis will be at this particular point, right? Isn't it? If you just shift it, right, this y-axis will move towards your left, right? So your axis will be at -2 in this particular case, and then we'll need to reflect it. Then you'll get a graph of something like this, right? Right. So once you have this y of -2 -n, right? Once you have that graph, we just need to perform multiplication of it. So at -6, it's 0, right? There's no value for x of n. So -6, at -6, it's 0. At -5, it's 0. At -4, it's 0. At -3, we have a value of 1 for y of -2 minus n, right? We have a value of 1. And over here in x of n graph, at -3, we have a value of 3. So 3 multiplied by 1 will give me 3, right? So there you go, we get 3. Then at -2, we have a value of 0. In this particular case over here, 0. And over here, we have a value of 2. So 2 multiplied by 0 will give me 0. Likewise, you do it for the rest of the points. You end up getting these particular points, right, up till 2. Because after 2, there is no other points present in this particular graph, right? So you end up getting points up till 2. So there shouldn't have been a point at 3, right? Because at 3, the value here is 3, but the value over here is 0, right? You can see in this particular case, the value is 0, right? So this should have been the graph that you would have got, right? Most of you couldn't draw this. You made a error transforming the graph, right? Using the transformation properties, right? Then part B was to consider the discrete signal x of n is equal to 3n u of -n plus 3. And the digital filter h of n is equal to u of n minus 2. Find the output response y of n and sketch y of n, right? So in order to obtain y of n, the first thing you'll need to do, right, you have two options. You can directly evaluate it using the formula, that is the summation of y of n is y of n, I believe, is equal to summation of, sorry, x. Let me just erase this. I can just search it. The formula for discrete Fourier, discrete convolution, sorry, formula is given by this particular formula, right? Wait, images. Okay. So, okay. So y of n is equal to summation of x of k multiplied by h of n minus k, right? So the first thing, you can directly substitute your formulas in this particular case, or what you can do is actually make the graph. What I'd say, what I would suggest you guys to do is usually try to draw the graph, because directly evaluating using this formula will be slightly difficult, right? So if we do that, right? So if we do that, so the graph of x of n will be something like this, right? 3 to the power of n, it will increase towards positive side, but towards the negative side, it will decrease, right? It will decrease to 0, right? And it is continuous, right? Okay. So this is the graph you'll get. If I had to draw it in terms of a continuous graph, though this is a discrete graph, right? We're talking about discrete signals, but usually just roughly sketching it, you can sketch it using a continuous line, right? So your graph will be something like this, and it will stop since it is being multiplied by u of negative n plus 3. So basically it will stop at 3, right? The graph will stop at 3, and so your graph will stop at this particular point, but it is continuous towards negative infinity, right? So you get something like this, right? For your x of n graph, right? For your h of n graph, right, it is u of n minus 2. So u of n minus 2, again, it is u of n minus 2. It is a unit step graph, but shifted 2 units towards your left. I mean towards your right, right? Okay, towards the positive side of the axis, or you move the axis 2 units to your left side, right? So drawing u of n minus 2, you should be getting a graph of something like this, right? The graph drawn in blue, right? So now this could be represented as if it was a continuous graph, it would have been something like this. If you just need to roughly sketch it, right, with an amplitude of 1, right? This is a straight line, right? Should have been a straight line. Okay, now you have the graph of x of n, h of n, right? This is x of n, h of n. Based on the formula, you need to translate x of n into x of k. So basically replacing n with k. And you need to change your graph h of n with n minus k. Basically what you need to do, you need to reflect the graph, isn't it? You might have learned this in 2 to 4, right? When you, in order to compute the convolution, you need to reflect the graph, right? H of n minus k is basically the reflection of the graph, right? So it is a reflection of this particular graph here, right? Based on the formula, right? Now, once we have our x of k and we have our h of n minus k, right? What do? We just evaluate it, right? So now direct convolution, if is this part, if we have the graph of something like this, right, over here, okay, yeah, we have the graph of something like this, and we have h of n minus k, or reflected graph of h of n, right? in order to compute the convolution, it will give me something like this. It is going to be continuous towards the negative infinity side, right? So it is continuous, meaning there will be 1, 1, 1. The graph continues as it approaches negative infinity, right? So the reflected graph is something like this. So based on this, if let's say if I had to roughly sketch this is something like this, right? Isn't it? So if I had to sketch it over here, you can see this particular portion, this overlapping portion is just the amplitude of 1 multiplied with the amplitudes of this particular graph, that is x of k, right? In this particular case, I mean x of k, yeah. So it is given by, basically it is given by 1, right? 1 multiplied by the function of this particular graph, that is 3 of n. If n is less than n minus 2, sorry, this particular point, that is n minus 2, right? This particular point, that is n minus 2. If n minus 2 is less than 3, the graph is 1 multiplied by the amplitude of the graph, that is given by 3 to the power of k, because this 3 n u of n minus n plus 3, this u of n u of negative n plus 3, the value of this is a unit step, so the amplitude is just 1, right? So we can avoid that. That has already been translated on this particular graph, right? So once we have done that, right, we have something like this, right? So that is why there is no multiplication of 1 here, since this is a unit step itself, right? It has an amplitude of 1. So the value of h of n minus k in this particular case is just 1, right? So when n minus 2 is less than 3, when this n minus 2 point is less than 3, the summation or the convolution is just given by y of n is equal to summation from k to the power of infinity. I mean k with a lower limit of negative infinity and an upper limit of n minus 2, because the lower limit is towards the smaller value, isn't it? In this particular case, both the graphs are continuing towards the negative infinity side, isn't it? So your lower limit is negative infinity, while your upper limit in this particular case is n minus 2, right? As long as n minus 2 is less than 3, this statement is true, right? Okay. So we can use our properties for summation in this particular case, and we'll be ending up with 1/6 multiplied by 3n, right? Is that fine? So n minus 2 is less than equal to 3. That can be translated when n is smaller than or equal to 5 as well, right? You can leave the condition as n minus 2 is less than equal to 3, or you can simplify it by taking this negative 2 to the other side. That will give us n is less than equal to 5. This is just a condition. It's not reflected in this particular formula, right? The formula for convolution. That is one situation. If this particular point, right, let's say the graph of y of n is, sorry, the graph of h of n minus k, the situation, this another situation, sorry, right? When n minus 2 is greater than 3, what happens if n minus 2 is greater than 3, right? That is, if the graph starts after 3, that is starting at somewhere over here, right? If the graph of h of n minus k starts after 3, right? Okay. So if the graph starts at this particular point, the whole of the graph of y of the whole of the graph of x of k is overlapped, isn't it? Right? If your h of n minus k graph, or when n minus 2 is greater than 3, the h of n graph overlaps whole of x of n graph, right? So that is another case. So in this particular case, since we have already covered the discrete point of 3, so in the next particular point, starting from the next immediate discrete point, the graph starts to cover whole of x of n, right? So that is what we can see. So basically, in this particular case, it will be the summation from negative infinity till 3, right? So the lower limit is negative infinity in this particular case again, because it is the lower limit, right? Because both the graphs are extending towards negative infinity, but the upper limit is defined by x of n, right? That is x of k if we substitute it into the convolution formula, right? So it is defined by this. So in that particular case, our upper limit is 3. So that is what we have. And again, it is basically the summation of 3 to the power of k, right? Whatever value we have. So that's how we get the upper limit of 3 and the lower limit of negative infinity in this particular case. And if n minus 2 is greater than equal to 4, which is the condition, right? So again, you can simplify this by taking this negative 2 to the other side, we'll be ending up with 6, right? So this is just a condition, n is greater than equal to 6, just is a condition. And this is also a condition. It does not mean much, right? It is just a condition. So once you have evaluated this part as well, right? You have evaluated the summation from negative infinity till 3 using your, what do you say? Using your summation properties again, you'll be getting 81 upon 2, right? So we have two y of n properties, right? I mean, two y of n values. So based on that, it will be a piecewise y of n, isn't it? Because if n is less than equal to 5, we get 1 upon 6, 3n. If n is greater than equal to 6, right, or n minus 2 is greater than equal to 4, we end up with a total convolution value of 81 upon 2, right? So all of you get how we evaluated this conclusion? Okay. So there was two situations, right? This is just a simple situation. So I guess everyone gets it right now. But however, in your papers, no one was able to do this convolution, unfortunately. I think it could have been just because of the formula. I mean, most of you just tried to evaluate it using the formula. So in that particular case, there's a misunderstanding of which limits to use and which limits not to use, right? So if you are able to draw this, right? Okay, someone just asked, so can you explain how we get 1 upon 6, right? So 1 upon 6, we can rewrite this whole formula using this summation. Let me just look up for these summation properties, right? Okay. All of you can see view my screen, right? I guess. Summation properties and rules. Let me see. Where is it? Okay. Just hold on a sec. Let me look up for a table or a table for properties of summation, which you can use. Summation rules. Let's see. Get this. Actually, no, the solution given over here is correct, right? So let's try to figure it out over here, right? Mm, just trying to look up for that particular table, the summation properties. I'm not sure if you have that properties with you or not. Do you guys have the summation properties with you? The summation rules? So these are just some of the rules, right? These are some of the rules, and then there is another rule for summation of infinity as well, right? Summation till infinity. So this is one set of rules, and then there's another set of rules. Uh, mhm. It's yeah, I know it's one upon one minus k. So in this particular case, in this particular case, we can split it up from, I think that summation is from 0 till infinity, right? If that's the case, then we can split it up and then find the inverse of it, rotate the inverse. Yeah, so we can rotate the, let's try, I can write it down on the screen. So we end up with two sets of summation, that is summation of 0 till infinity, sorry, we end up with we can rewrite this as summation of um, negative infinity till 0, right? That is k is equal to negative infinity till 0 of 3 of k plus summation of k is equal to 1 till n minus 2 of 3 of k, right? So in this particular case, this one switches the limit, and we find the inverse of this. That would result into summation from 0 till infinity of 1/3 k, isn't it? If we rotate, then we rotate the sorry, switch the limits, right? We'll be ending up with this, right? And we're left with plus summation from k is equal to 1 till k is equal to n minus 2. So we have two properties here. So solving for this, I think we'll be ending up with 1 upon, like, the summation of this particular part is going to leave me with 1 upon 1 minus 1/3, I believe, right? Is that right? And the summation for these, yes, right. So the summation for these, the second part, this second number will be just a reminder, right? If this meeting ends at 40 minutes, please rejoin again using the same link, right? So let me just close this off. In this particular case, summation of 3 to the power of k is given by okay, let's try to rewrite this summation. That would be k is equal to 1 till n minus 2. If we make let's write L is equal to k plus 2, we can rewrite the summation. It would be summation of, let's assume L is equal to k plus 2. So in that particular case, k will be equal to, over here it will be equal to 3. And the summation at the top will now change to just n. And then the summation of this will be left with 3. It will be k is here, so that will change into L minus 2, right? L minus 2. L minus 2. So now if we have L minus 2, then we can further break it down. Okay, let me just say that I'll email all of you the actual expanded solution for this particular part, right? Is that fine? I'll email all of you because at the moment we are running out of time. I'll email you all the solution of this, right? Okay, the expanded form, how we do it, right? Okay, next is moving on to question number 3. We are running out of time here. Is this? Okay, question number 2. For problem number 2, in this particular case, we did not have to worry about this structure 1. I mean, is it form 1 or form 2, right? Is it structure form 1 or form 2 of this particular system, right? We just needed to derive the difference equation. So what we just needed to do was just to label it, right? To make it simple, what we do is at each point we label the signal, right? So in this particular case, we can assume this whole signal, right? X of n is divided, I mean, it is separated by some delays and some constant multiplication, and it ends up with a summation sign. So we can label at this particular point as 1, right? I mean, 1 is u of n, right? We can label this particular point as u of n, right? In this particular case, we can label it anything, right? Regardless of that. And then after that, that u of n goes through a delay block, right? We can leave that. Even if you want to label it as wn, you can label it, but I would suggest just leave it like that. And then that block goes through another delay, right? Since we can see that there is a delay, we can label another signal at this particular point because the output is phi of n eventually, right? So based on that, labeling, I mean, identifying the points where you want to read the signal outputs, right? Based on that, then you can, what do you say? This is basically dividing the whole block into separate blocks, right? So we can assume that this is one system, this is one system. We can assume this is one system, isn't it? We can assume that this part is a whole system itself, and we can assume this as a whole system as well, right? Isn't it? So that is what is being done here. So if we consider this as one whole system from here till here, and we label this output signal over here as u of n, right? Label that as u of n. So we can write u of n in terms of x of n, isn't it? So we can write u of n in terms of x of n. So that would be, if we take this first part from here till here directly here, that would be x with 2 delays, that is x of n minus 2 times 2, right? So this is what we get, right? The first part. The second part would be x of n going through 1 delay, right? This is second part. X of n going towards one, through 1 delay block, and then it is multiplied with -1, this part, right? So this is your second part. So that would be x of n minus 1 multiplied by -1. So we'll be getting negative x of n minus 1. So that is what we get over here, right? And then this is the third part of x of n signal, that is x of n. It doesn't go through any delay, and it just goes through a constant multiplication of 0.5, and it goes to an addition block, right? So that would leave us with 0.5 multiplied with x of n, right? So this is one system, right? So the equation for one of the system, right? Then we take this as one system, u of n, with omega n. I mean, your input signal is u of n, your output signal is omega n, wn, right? So in this particular case, your wn is equal to u of n minus 1, right? So that is what you're getting. Wn is equal to u of n minus 1. And then if we take this as one system, right, that is your input signal is wn, your output signal is v of n. So basically v of n is equal to wn minus 1, right? Isn't it? Then we have that, right? V of n is equal to wn minus 1. We know that wn is a single delay of u of n, isn't it? So what we can do is we can write v of n as u of n minus 2, right? I want all of you guys to rejoin this meeting. So I'm ending this meeting right now, right? Then we'll start again from here where we left off, right? I hope that is fine because we are running out of time. I'm limited to 40 minutes per session. So please rejoin again quickly. I'm ending the meeting. Right. Ending the meeting. Please rejoin again, right? Rejoin again.